Ion pump and ion exchanger. ATP dependent ion pump and ion exchanger is the title of the lecture 2 of session 2 in the membrane and receptor module. As you know, homeostasis is very important to maintain stable environment in the body, and you learned how the organ system all work together in order to maintain stable environment of the body, through hormones, through organ systems, and in order to prevent change the level of the solute, of the nutrient, of the fluid volume or blood volume from going too far from the normal. So homeostasis is very important, but what will happen if the body homeostasis affected, or the plasma blood homeostasis affected, or um, these may affect the cells, the environment of the cell. So the homeostasis is important to prevent change in the environment of the cell. What's the environment outside cell? It's interstitium. And interstitium osmolarity is the same as the plasma osmolarity, and it's also about the same as cellular osmolarity. So when interstitium change due to plasma change, the osmolarity of the cell also change, and so on. That's why we have to maintain stable environment outside the cell and inside. So if the homeostasis cannot work and interstitium or cellular environment change due to any cause, the cell should have mechanism to resist these changes or to adapt to these changes, because cell is the most important and functional unit of the most organs, all organ system, and all cellular process will be affected if the homeostasis of the cell affected. So the aims of the module is to outline the major physiological role of the several transporters that are present on the cell membrane and inside the cell. And it's also aimed to consider how ion transporters work together in cell physiology, and to consider how ion transporters contribute to, so these ion transport important to control, resting intracellular calcium concentration, cellular pH regulation, cell volume regulation, renal bicarbonate absorption, and renal Na handling. So they have all these functions. You know, ion distribution across the plasma membrane is different. For example, as you can see in the figure, sodium is more, sodium and chloride mostly present outside. لأنه دروي السيل كان هياخد لبلازما زورترا extra cellular NaCl طبعا شي خوي بوابي لكيوتو خوي لدروت زياترا. Well, طبعا HCO3 bicarbonate, but potassium, phosphorus and protein more inside. You can see there is different the concentration of sodium in the inside and outside. There's great amount of sodium outside, and which create it's responsible for most osmolarity of the extracellular fluid. While we said the osmolarity of the outside and inside of the cell is the same. How this happen? Through what? Of course, first we have protein here inside the cell. That's why osmolarity is the same. And how this Na not come to inside the cell in order to maintain gradient. باش إلا شوينك solute يزور ببتناو سيالكا ولا شويني زورو بو شويني كم بوشي أو ناكاد بو يا potassium ناتشي تدرو. Because of the action of several transporter proteins that are called ATP dependent ion pump or ion exchangers. It's called ATP dependent because use ATP. They work against gradient, against concentration gradient. You know NAK-ATPase, you learned how it works. NAK-ATPase is one of the important pumps. It's called also Na pump. It's a primary active transport because it directly uses ATP. It will bring sodium, expel sodium, 3 sodium, and it will bring potassium to inside the cell, 2 potassium to inside the cell. That's why it maintains the concentration gradient of the low sodium inside and high potassium inside. And it's important, this gradient is important in order to drive many other cellular processes like ion homeostasis, pH, intracellular pH. intracellular calcium, cell volume regulation, resting membrane potential, and so on. Why control of intracellular calcium is so important? Why calcium concentration should be maintained? This level should be maintained. Inside of the cell, we have low calcium, and this low calcium should be maintained because calcium is toxic to the cells. کاتێ لەو لیڤڵایە هەمان بێ نابێت زۆرتر بێ چونکە تۆکسیکە ئەگەر بۆ ماوەیەکی زۆرتر بمێنێتەوە بەو شێوەی بەرزیە ئەبێتە هۆی چی؟ Toxicity to the cell and may cause damage to the cells. So, as you can see, there is an approximately 20,000 fold difference in calcium concentration across plasma membrane. ئەگەر سیرکەن لێرە لە دەرەوەی لە extracellular fluid calcium چەنە؟ طبعا هەر کەمە بەڵام لە چاو ناو سێڵەکەیە زۆرترە. It's about 2 millimole, while calcium inside the cell is about 0.0001 millimole. So you can see this great difference between calcium concentration inside and outside, and this gradient should be maintained. Calcium should be kept low inside, except in some cellular processes. During this cellular process should increase calcium inside the cell. So it's important to control resting calcium inside the cell. چون control resting calcium كاين؟ چون أو calcium هر أوا بكمي بمينتوا. How the calcium that is present more outside, you know the gradient is like this. Calcium is more outside, less in the inside. How this gradient not driving calcium to inside the cell? Through several transporters. transporter أنا هرهم ويكاركن كشبكن to decrease calcium inside the cell during resting condition. أكاتي restinga أبي calcium زور كم به transporter أنا إيش كان. The most important one is NAK-ATPase. NAK-ATPase زور جرينجا زور بس اللي كانوا أبيته هو driving force for the action of other transporters. When NAK-ATPase work, it will cause Na gradient. It will the Na become low inside, and this low Na acts driving force for the activation of sodium calcium exchanger. Sodium calcium exchanger normally during resting it's work like this. It brings sodium in and expel calcium. كاتسي sodium ينتجور calcium يبعت دروا. أما بوشي باشا وتمانا بيه كالسيوم كم بيه لنا وخانكيا. So this is one of the most important exchanger or transporter. It remove large quantity of calcium to outside. That's why it's said it has high capacity. بويالين high capacity چوكا تواني كالسيوم يكي زور لما يكي كما بريتا در. It has low affinity because low affinity چیه؟ يعني تواني بايندينجيز بسبستريتا كوكا كالسيوما كما low affinity. وهذا چی؟ هذا كاتك كالسيوم زورة انجا activate به. When the calcium is low, this exchange will not so active. Okay. Let's see other transporter. We have other transporter that also cause decreased calcium inside the cell. One of them is plasma membrane calcium ATPase. We have two types of ATPase. This is plasma membrane calcium ATPase that expel calcium. يعني لنا سلك كميات ويكات دروا. And we have sarcoplasmic reticulum or endoplasmic reticulum calcium ATPase. هر همان إيشكا تشيكا كاركي تشيا calcium كما كاتو لنا سلكا. Gringoya calcium كم بيتو لنا سل. The plasma membrane calcium ATPase bring calcium to outside, while that of the sarcoplasmic or endoplasmic reticulum it will bring calcium to the sarcoplasmic lumen. أي خاتنا lumen كوا. Gring أوي تشيبكا لنا سلكا كميكاتو. So it is an exchanger with proton. كالسيوم تشتنا سلكا بروتونية تدرو. Another transporter is calcium uniporter inside on the mitochondrial cell membrane. The cell membrane mitochondria چی من هست؟ transporter یک من هست که بیالن calcium uniporter. که چیه کد؟ It will remove calcium to inside this mitochondrial lumen. calcium بات ناو lumeni mitochondria که. أما كاتێک کارەکە کە کالسیۆم زۆر بێ it will act when the calcium is very high in order to prevent damaging effect of this great amount of calcium inside the cell. کاتە ئەمەوەکو buffering effectێکی شەکە mitochondria. As you can see, the calcium ATPase is called what? High affinity, low capacity. Why it has low? It's called low capacity because it only works when the calcium is lower. كالين lower يعني چی؟ calcium يموتمان high بي كاتا دروانيا بلام كاتي calcium أما إن calcium exchanger صار بي calcium كي بردادر calcium كم بوا بلام هشتا نجيشتو تو normal. So when the calcium is low but it doesn't reach the normal level, it is still high. So it works in this condition because it has high affinity. يعني جي high affinity يعني binding يبقى calcium كوبا substrate كو زورة يعني جي when the calcium even the calcium is low it binds with high affinity to the calcium in order to remove residual calcium. كاتو calcium أو باش ما calcium كما ولا نوصلك أو هشتا زيادة أو أكات دروا أمش بهمان شيء. So these are the same repetition of the same previous slide. We have different mechanisms to control resting calcium. Primary active transport كأمشيكا بيمكا كتبلازما membrane calcium ATPase. Secondary active transport كتشيا sodium calcium exchanger. We have sarco and endoplasmic reticulum calcium ATPase. And we have mitochondrial calcium uniporter. Sodium calcium exchanger, as we said, it exchange sodium for calcium, 3 sodium in, 1 calcium out. So it is an electrochemical gradient. Create an electrochemical gradient, electrogenic. Why it's called electrogenic? چونکە potential difference دروست دەکا. وەکو ئەبینن 3 sodium بێنێتەوە یعنی 3 زائد while bringing 1 calcium out calcium potential چیە زائد 2 کاتە 2 زائد ئەباتە دەر. So it create an electrical gradient or potential difference between inside and outside. Normally in depolarized cell the normal mode of Na gradient operation is inhibited أو Na calcium exchanger inhibitable لكاتي چيا من لنورماليشا when the cell depolarized. سبت أنا depolarized و polarized چيا and its mode of operation reversed. That is to say it brings calcium into the cell. In this way Na calcium exchanger make a contribution to calcium influx during the cardiac action potential. طبعا أنا زور قرنقا لكاتي muscle contraction بونمونا cardiac muscle contraction مع cardiac contraction calcium هنا تناوصلك چونك وتنزانن muscle كبيرسي بچيا it need calcium in order to contract. So inside the cell the calcium should be high but it become high only for short period of time, so not cause toxicity. Because some calcium dependent process require a higher calcium inside the cell, as we said, like muscle contraction. At this moment it's essential for the cell to raise its calcium inside the cell. كات لو كاتانيا بكالسيوم يناو سيلك اتشيلي بكا برزي كاتوا ببيتشوانو كاتا we have several transporters that cause increase in the intracellular calcium ببيتشوانو ما نبنى هوي calcium زياب كان لنا سيلك. But as we said this is instantaneous, so يعني زور فوري زور لبرو خيرا تشيكا calcium زياكا طو أقرأته بنورمال. شون أقرأته بنورمال أو calcium زورينا سيلك through the other transporters that we discussed that control low cellular calcium during resting condition. كاتما لكاتي تشيا لكاتي activity لكاتي contraction أقر ببينن أمام transporter man هي store operated, receptor operated, voltage sensitive channel. They bring calcium to inside the cell and in a calcium exchanger as we said it reverse ببيتوانو كاركا calcium هنتناو صوديوم باتا درو بوشي وتما لو كاتا cell depolarize بوا واتا چي depolarize طبعا أما cell membrane normally چی من هەیە negative inside positive outside ئەمە normally کاتێ وا بوو ئەڵێن چی cell polarized ئەمە لە کاتی ڕستینگە بەڵام لە کاتی action potential لە کاتی depolarization چی ڕۆیە depolarization یعنی پێچەوانە بێتەوە there will be positive inside through what through sodium entry sodium flashەکە بۆ ناو سێڵەکە سۆدیۆمێکی زۆر ئەبێتەوە ئەوەی کە ناوە ببێ بەزائید when sodium increase inside what will happen the sodium gradient ئەم جارە زۆرە بێ لە ناو سێڵەکە so sodium go out so the Na calcium exchanger will reverse ئەمەش هەر نۆرماڵە باشە ئەبینن کالسیوم یونیپۆرتەریش بە پێچەوانەوە ئیشەکە شتی کەشمان هەیە بەڵام ئەمانە لە لێکچەرێکی ترا باس ئەکەین this mechanism that causes increase in the calcium how Na calcium exchanger work in ischemia ischemia چیە یاخود myocardial infarction the beginning before death of the cell myocardium لە کاتی جەڵتەی دڵایە لە کاتی زەبحەی دڵا چیمان هەیە مولو لە خوێنەکە تەسکە بێتەوە خوێن کەمەچە بۆ دیواری دڵ so there will be decrease in the blood flow decrease in the oxygen so decrease in the ATP production when there is no ATP or less ATP what will happen Na potassium ATPase cannot work normally activity کەمە بێتەوە کە کاری نەکرد there will be decrease in the Na inside increase in the Na inside وەکو depolarize بێ سەڵەکە Na لە ناو زیاکە when Na inside increase what will happen لەبەرەوەی Na لە ناو سەڵ زیای کرد there will be increase or a change in the direction or reversal of the Na calcium exchanger کاتە چیەکە ئەم جارە calcium ئەکاتە ناو سەڵەکەوە and although this is an important process during depolarization normally but depolarization is only it lasts for few milliseconds millisecond يعني بويا toxic نية بلام لكات ischemia during whole period of ischemia there is high calcium remain inside the cell and it will cause toxicity أما همان شتا in normal condition or healthy cells you can see sodium calcium exchanger activity this is normally when the cell polarized calcium go out while when the cell depolarized أبين ناو زائدة چونك صوديوميكي زور هاتو تناوى بهوي چوا action potential and depolarization so when sodium is high inside the sodium calcium exchanger reversed it will bring sodium out and calcium in so increase the calcium this is as we said important for contraction and other cellular process because it's only for short period of time while during ischemia what will happen is the same as we said ATP depleted so sodium pump inhibited and there will be depolarization of the cell and the sodium calcium exchanger will reverse and as we said it is toxic because high calcium inside the cell is toxic and thank you